Manufacturing Hub. A very special episode today. If you're new here, welcome. If you've been here before, welcome back. One quick big announcement. If you guys have somehow managed to miss it, next week, just a couple of days from now, I will be at Hanover Messe in Germany, actually with the Litmus crew. So thank you, Litmus, for sponsoring this theme and hauling me out and giving me a home in a booth next week. So I will be there. If you guys are going to be there, please come and say hi. Come hang out for a little bit. We're going to do a bunch of other things. I just got like 27 calendar invites as to things that I'm going to be doing at some point next week, including we've got a presentation on Wednesday. So if you guys are going to be there, come hang out, come say hi. I will have Manufacturing Hub stickers. It will be a good time. We will be in Hall 17, booth F18. And we'll say this again, but if you guys are going to be there, please absolutely come hang out with that. That should be super amounts of fun. If you guys are new here, we certainly try to have an open conversation. Kevin, as we'll introduce in just a couple of minutes, has got an awesome background. If you guys have questions about Kevin's background, about any of the topics that we're talking about, please feel free to go ahead and kind of throw those in any of the chats. We do our very best to get to that during the live show. And if we don't get to that during the live show, we do our very best to get back and try to answer those questions. And sometimes there will be super technical questions that, as much as Vlad and I would love to go drive the next 35 minutes of the show into those technical questions, just is not the right time or place. But we do our very best to go continue to have conversations with folks offline, drive our guests and everyone else to go have those conversations offline. But no, again, I'm mostly planning next week, and that is kind of the big thing going on in my life and in the life of Manufacturing Hub. I think we'll have, assuming the internet is good, somewhere between like 6 to 10 lives that we will go bring some booth stuff back to you guys. So without further ado, let's go ahead and kick off. I'd like to officially welcome everyone to Manufacturing Hub with me, Dave, this guy up here, Vlad. We again want to thank Litmus for sponsoring this theme, talking about high impact solutions. We'd like to welcome our guest, Kevin Holbrook, to the show. Kevin, welcome. Thank you for being here.
Thank you, Dave. Thank you, Vlad, for the opportunity. Wonderful to talk to you, gentlemen. And thanks to Litmus Automation as well for making this opportunity possible. I had a chance over the last year or so to work closely with the Litmus team in the field. Wonderful bunch of guys. They have a wonderful product. And we were able to actually address a few real use cases in the field. So that was wonderful.
Awesome. Thank you so much for taking the time, Kevin. Before we dive into the technical conversation, I really want to get your background. I know that you've been into very high-end roles in many places, so I want to get to know you a little bit better. How did you get started in the industrial automation path? And ultimately, could you walk us through your experience?
Excellent. Thanks. So for about the last 15 years, I've been either directly in industrial IoT or orbiting around the ecosystem. So about 15 years ago, I joined a company called Exida. So we were the leading platform for remote monitoring, remote management of largely medical devices. We were in 4 or 5 divisions of GE. So it was equipment monitoring, equipment management, firmware over the air, remote sessions, remote control, things of that nature. And so I was there for about 6 or so years until we were acquired by PTC ThingWorx. And we sort of did a best of breed combination of the two. I was a middle manager. If you folks have been in acquisition cycles, you know how this story ends. So I was there for about a year to the first stock cliff. And then I went off and I joined Momenta Partners. So Momenta is an investor, largely early stage, early revenue, some pre-revenue for industrial IoT companies. I spent a year there. I actually met the Litmus guys for the first time, I think about 6-7 years ago, when they were still in their infancy a bit, and did a little bit of M&A, a little strategic advisory work there. Then I joined the Azure team. So I joined Azure. I was dedicated to Schneider Electric. So I was largely working as the interface between Azure and Schneider, working on their IoT platform and their rollout. And after about a year and a half, I joined the GCP team. I was recruited away to go join Google. There's a longer story there about, I technically worked for Microsoft France. So my team was all in another continent. And I kind of was hungry to have a local team again. So I went and joined Google. I was sort of doing generic cloud sales for about, the first 3.5 years. And then last year, I was able to hop over to the Manufacturing Solutions team, get back to my people, and we were in the field with Litmus Automation, connecting factories, getting data to flow up to GCP, and applying ML and AI there. So had a lot of wonderful experiences with a lot of great people from a lot of different, both ISV, advisory, and cloud infrastructure perspectives.
Very interesting. I see like the very diverse sort of, you touched many different areas, I want to say, of industrial, cloud, networking, software, hardware. I guess I'm curious if I can ask you, how do you position yourself? Are you a generalist? Do you manage? Do you work? You say you worked in M&A, so obviously there's finance involved, there's some strategy involved, there's also heavy on the tech side. Do you consider yourself like an engineer? What's your current perspective on all those different roles?
Sure. So I had a wonderful opportunity last year along with the rest of my team. So it was ultimately our downfall. We were all garbage collected in the layoffs back in January. But in the manufacturing solutions team, after I joined, we were sort of allowed to do whatever it was we wanted to do. So we had executive sponsorship, but we were given almost complete freedom to go attack this problem. So what was really good about that was I got to figure out who I was when nobody was looking. When nobody was telling me what to do, I got to find out who I was. Some folks who came from the exact same roles, the exact same background, ended up writing code all day. They ended up in the IDE, they ended up building the solution and deploying it. Some folks ended up doing analytics, dashboards, visualizations. I ended up selling stuff. So I ended up in front of customers running the POCs for the Americas. So that happens to be who I am when nobody is looking. So, I loved the management path. I got up to senior director. I liked the fact that, you can grow a team, build a team, go from 0 to 1, and actually go out and solve problems. But I sort of realized later in my career that I could be just as much of a leader without having to fill out the paperwork. So I prefer to just be a senior individual contributor, help drive the team forward, provide leadership and guidance, but without having to actually do perf reviews.
And I guess, like, from my perspective, and feel free to correct me if I'm wrong, but sales, a lot of times, especially in the cloud space, it's educating the customers, right? It's still understanding the technical aspects quite
Mm-hmm.
heavily, right? So it's not maybe like a pure marketing role, which it could be perceived as, but it's a lot more. You needed to know very well the services that, in
Yeah.
this case, like GCP provided, but ultimately on any cloud provider, you need to be very familiar with the platform. So it's very fascinating, I guess, like how quickly you manage to grasp those technical aspects, because I know like cloud is fairly complex, at least from my perspective, and I know that a lot is possible, and I think that manufacturing is slowly starting to
Mm-hmm.
adopt cloud solutions and slowly starting to see what's possible, but it's certainly not, how to say it, not at the point where I would like it to be, and it's, I think we're getting there, I guess. Any thoughts on maybe the adoption of cloud in manufacturing, like specifically in the industrial space?
Sure. So, I mean, it's tricky, right? We're going to hit the OTIT boundary conversation
Yep.
immediately
Yep.
here. So, we have a group of people who are paid well to say no to us. Our desire is to exfiltrate data, to get it up to the cloud, to do wonderful things with it, to, as we're marching up that maturity curve, to talk about adaptive controls and predictive maintenance and everything that, the executive tier wants to hear. But then in the IT side, they say, what ports do you want me to open? What operating systems are you going to run inside my OT network? So there's this constant struggle of, the IT world where we might say, hey, let's just open the port, man. We've got a firewall, set up an interconnect from the corporate data centers, and everything's happy, right? And then you have the OT side where they're worried about infiltration. They're worried about any devices on the shop floor interfering with the equipment or hopping from whatever device you put in there, and a sideways attack to go over to other controllers. Everybody has probably heard of the Stuxnet virus and that attack vector. So that's fresh in the minds. If you introduce software into that environment, it's inherently a risk. So while I think at the executive tier, the management tier, there is a desire to get that 360-degree vision to see all of their plants at once in a single pane of glass, there's a very pragmatic and very real objection to any newly introduced devices. And I'll expand on it just a little bit. I think in the cloud world, containers are the currency, right? Docker containers. And every solution you come across is containerized. I've worked with a few IoT startups or early stage companies, and they're all just driving forward. Okay, it's a containerized solution. We deploy containerized applications. The OT guys do not know what Kubernetes is. They don't know what a container is, and they're not interested in finding out. They've got an ESX server. They've known VMware for the last 15 years, and they want to understand which VM they should deploy, because it's the currency they're used to. It's how they know how to manage it. So we're talking about trying to get them to move into the future. It's not just getting data out. It's trying to get that OT mindset to adapt to what has become the currency of the cloud and the modern technology stacks.
I would play, devil's advocate on maybe the last statement of Kubernetes and Docker. I feel that on the OT side, you don't always get to see the full sort of like ROI or maybe benefits of what
Sure.
that deployment's going to look like for specifically, cases out the door. And so it becomes very difficult to get invested, I want to say, in these
Mm.
early stages where we're trying to figure out the true value, right? And so it's, how to say, like, I've certainly seen the exact scenarios that you've talked about where you lose OT guys when they don't see the potential. They don't want to understand technologies that may lead to hypothetical ROI. But anyways, I think it's going to be interesting. I think that more and more organizations will deploy sort of a structure where you have an IT OT expert, and that's someone who's a generalist across both, who can, I want to say, effectively lead those projects, right? Because for now, again, if I'm on the OT side, I have KPIs that are driven by cases out the door. I want to
Mm-hmm.
make sure that I'm creating quality product. And then on the IT side, obviously, you've mentioned a lot of like cybersecurity, a lot of data handling. You have your servers. So I think the KPIs are somewhat separated, right? So if there was a person that could reconcile that, it would be ideal. But I guess, what are your thoughts on moving forward? What makes sense? I think Dave and I had this conversation a few months ago where, one camp is we should have a complete sort of like wall between IT and OT, where, if I'm, let's say, on the OT side, I program my PLC, my machinery, then I want to know nothing about the servers. I can just tell the IT team, hey guys, I have this data coming out. You do whatever you want with it.
Mm-hmm.
Versus there's this merge that a lot of companies also talk about where you have a person that sort of transmits the information. I wonder what your thoughts are on that.
So it's a great question. And I think it really depends on how dogmatic the OT folks happen to be. So I
Mhm.
ended up in a conversation last year where we were talking about, this is with Litmus Automation, we were talking about a gateway, talking to a local historian, and then there was discussion about potentially talking to some SCADA systems as well. We were having a many meeting long debate about whether in the Purdue network this was layer 3 or whether this was layer 3.5. And should there be two gateways? Should be the layer 3 gateway and the layer 3.5 gateway. And I think to the extent that that old school dogma still permeates the discussion, it's going to be hard to get rapid adoption of anything that's going to be sending data out. And then more crucially, sending data back down. When you talk about AI and ML, which I know we're going to be getting to,
Yep.
you need to round trip. If we're talking about adaptive controls, that's also a round trip. So getting the first battle won, the exfiltration, the northbound channel established, is an easier fight than the southbound channel, where everything sort of looks like an attack vector, right? Everything looks like I'm sending bytes down the wire right to your factory floor, and then who knows what's happening. So I think it's
Absolutely. I would see the OT guys get really nervous with that statement, right? I
yep.
think opening up that traffic line back down is what scares most OT people. But
Mm-hmm.
no, absolutely. I totally agree with you, Kevin. I think it's going to be interesting to see what I want to say innovative companies do in the next couple of years, because I think there's going to be a couple of leaders who adopt a certain mindset and the
Mm-hmm.
rest is just going to follow, right? Like anything else, but they will have to have some kind of a framework, I'm assuming, or approach that would be documented. But for now, I haven't seen like a very solid, like this works for sure and this is how you should be doing it. I see a lot of experimentation, like I said, one way or the other.
Mm-hmm.
Dave, what are your thoughts?
Absolutely. I agree. And I think that this is a really good conversation. And I'm really happy that we can bring Kevin's perspective on, right? So he has worked with a bunch of groups who would maybe still consider themselves hyperscalers, right? And so coming from that, it's a very different conversation than we're having most of the time on Manufacturing Hub. But I think that that's exceptionally important. And I really like the comment of the round trip, right? Like we can do some amount of good, and we can debate the amount of good we can do by going and pushing data to the cloud. But similar to kind of any integration we talk about on the OT, on the shop floor side, we have to have that round trip, and then we've got to execute on that information that comes back in if we really want to make the proof of concept worth it. So having said that, Kevin, do you have some good examples of maybe sending data to the cloud, things that have worked well and maybe things that haven't worked well?
Sure. So I'll take you through an example of project that we worked on last year. And apologies, but I'll keep customer names out of it to protect the innocent. So we were working proof of concept for a single line that was processing raw soybeans into extracted soybean oil and then soy powder at the other end. And the heavy lifting for this was done by the European portion of the manufacturing team at Google, who is still there and still doing wonderful work. So the challenge there was, we did have a historian as our data source. So we had something reliable to pull from. There are some challenges with working with a historian. Those of you who have worked directly, you know that it's often just a hierarchical list of nodes. Often those hierarchical structures are meaningful, but when you get to the cloud and you're talking an MLAI use case, it's largely got to be a two-dimensional grid. So you need to do a lot of flattening. So a lot of the work that you did initially, you need to sort of collapse that down into a meaningful two-dimensional structure that you can start to do machine learning against. So we had very few issues initially with the connectivity. The Litmus team brought, their gateway, the Litmus Edge gateway, has 200 plus drivers. I mean, it can speak to everything that you could possibly need to speak to. Was easy, drop in. We talked to the OPC UA server. We were able to pull the whole asset hierarchy. It was trivial to do that. The challenge is now taking those tags, which are largely devoid of contextual meaning, in and of themselves, and setting them to the cloud and recontextualizing it in a way that it could be meaningful to someone else. So even when the plumbing is established, you still have a major challenge ahead of you. And there's sort of two schools of thought here. And I'm actually interested to hear what your thoughts are. So one school of thought is send everything to the cloud. Who cares? It's a fire hose. It's an infinite storage of infinitely elastic infrastructure. Just send the fire hose northbound. We'll figure it out later. And the other side is let's figure out what we're selling, have a justification. If we're trying to send, the most relevant signals, let's figure them out, filter them out, and send the relevant signals. We already have a historian, right? I don't need to pay you for another historian in the cloud. So I'd be interested from your perspectives, are you guys the fire hose or are you guys the laser pointer approach?
Vlad, would you like to jump on the grenade first or should I?
I can go. So I guess me and Dave diverge in that thought a little bit. So my perspective has always been that at least at the PLC level, at the field device level, you can collect a ton of data. And generally speaking, if you're not going to send that data at the very least to your historian or a data lake that's going to be off-site, it's going to be very difficult to go and get that data afterwards, right? So my approach is always, if you're able to get that data into a PLC device, then you should be sending that and historizing it, right? Because you can always, and I use always, it's also going to be costly to transform that data upstream, but at the very least, you already have that connection point and you have that stored in history, so you can technically go back and look at it, right? But obviously, when I say that, I put some caveats onto it also. I realize that you need to have more storage. You need to figure out, again, we talked a little bit about this off stream. You need to figure out how the data is being pulled, how much data are you going to store. There's different protocols. There's different ways also. You could limit, let's say, analog signals to be sent every millisecond when they're not changing. So you have to set up very smart polling techniques, create like deltas, create like over time. So there's a lot of nuances to that, but I generally have the approach of, if we have that data at the PLC level, we should be sending it to, at the very least, a historian.
I I would say on my side, I am certainly, if we talk about going to the cloud or going to anything above a process historian, I'm certainly the laser pointer approach, right? While I will be the first to say, and have said for probably a decade, that storage is cheap because we can always just slap another 16 terabytes into a server rack somewhere. On-site storage is cheap. The process historian tags, the sending it up in ever largening pipe up to the cloud storage, the cloud transformations, all of that becomes extremely expensive. So if there are reasons to go collect the information, I'm not opposed to storing it somewhere, hopefully ideally locally, I suppose, with the assumption that we have the tags and we're not going to go kind of the next step up on the process historian license and suddenly have to pay another $1, $2, $3, $4, $500,000 for the next 100, 200, 500,000 tags because we want to go store all of that. So I would say within reason, I am a let's go store the data, because as some people like to say, in theory, at some point 10 years from now, we might need it. But we need to go through the process of saying, hey, this is why we're storing it. And if we're storing something in the tens or even hundreds of milliseconds, we need to make sure that it makes sense to store them that quickly and that is going to be valuable, because if we're going to go store it and we're going to spend tens or hundreds of thousands of dollars over the next 5 to 20 years to go store it, if I need to go pull it 20 years from now, I want to be able to know that the data is good. I want to be able to know that we've done the work up front, and I don't need to go hire 2 data scientists to spend the next 6 months of their life to go try to clean this data before it goes up to the cloud.
Yeah, and I'm glad you mentioned the data scientists there. So there's sort of in the evolution, there's the data capture, there's going to be data aggregation. Then somebody needs to do the feature definition, feature extraction, understand what the important signals are, filter out the junk. Just because there's correlation doesn't mean that there's a meaningful correlation. The example that I always gave was you open your refrigerator door, the light comes on, and then the temperature goes down. So was that one event, or did the light coming on reduce the temperature? Right? They're all directly correlated with one another. They're not necessarily meaningful. So as the data scientist is going through the process, they have to filter out the signals that might correlate but not be meaningful. The current drawn by a VFD and the number of items moved along the assembly line, they might be almost identical because the VFD controls the speed of the assembly line, right? So there's a lot of this work that needs to happen. And I think the more noise you throw at these folks, potentially the longer that initial analysis process needs to take. We call it exploratory data analysis, sort of the first look at the bulk data set, trying to surface whatever the meaningful signals are going to be. So I'm mixed. When I worked at a hyperscaler, send it all. Send it twice, right? We get paid by the byte. But when it comes to actually the application of it, it's more challenging, I think, when you're giving this to a data scientist, and it's a very messy, very noisy data set.
Absolutely. I would agree. And my biggest kind of request after having gone through lots of data sets and people saying, yes, we've got data that lives on this old computer that goes back 20 years, let me export it via CSV and you guys can go have it, is so much of it is junk, right? And so much of it doesn't have notes or comments or anything worthwhile. I've seen, temperature probes that went to 0 or to 100, depending upon what they were scheduled to go to when they died, and just live at that for months or years in a row. Yeah. And so much of it is junk. My main hope is that if we go save the data, we know that it is good. And there are different ways to go make sure that the data continues to be good. And I suppose I don't want people going and saying, hey, let's go take all of the data. Let's go save all of the data. It will be important for you. And then down the line, when the time comes that we actually want it, we realize that we've saved 20 years of junk or 5 years of junk. And that while if we had the data, we could have squeezed that extra 5 or 25% out, because now we don't have the data. It's well, you guys spent a lot of money 20 years ago. You spent a lot of money every year through those 20 years to go save it. It's really junk. We basically have to start over, because there will be a lot of people upset 5 to 20 years from now that they're just sitting on junk data and they can't actually use everything that they thought that they could, whether it be in the cloud or whether it be sitting on spinning hard drives and servers.
Excellent. So it's interesting that we mentioned this sort of useless data. One of the main hurdles we were trying to cross last year with the Google Litmus partnership was contextualizing the tags while they were coming in.
Mhm.
So, no matter what, everybody's got a temp underscore tag underscore 14, right? And one guy knows what temp tag 14 is when he said it, and he's going to retire eventually. And who knows who's going to replace him? Because every plant I visited has dozens of openings that they cannot fill with a human being. Nobody steps up to do it. So one of the challenges we had was trying to give as much context and as much metadata around the tag as possible at the time we were storing it, because we will lose that tribal knowledge. We'll lose the loop where we can ask what the original design intention was.
Yep.
So in two of the big POCs that we did last year, one, we were wildly successful. This was the ag company. We had great engagement from the customer. The lead on their side coordinated well, got us all the information we required, got us the exports, got us the asset trees, helped us do the mapping, and it was great. On the other side, another POC we did for a cleaning product manufacturer. It's still process manufacturing, although it's a lot more constrained, right? The raw materials or chemicals are well known. It doesn't vary like biomass does. But they had nothing defined. And the tag mapping process, the contextualization process, was literally pinging a poor dude who already had a job, had a full-time job, and then some, and saying, hey, man, this is an interesting thing. What does this tag mean? And he'd actually have to go through the step logic. He'd actually have to open it up and see what was being sampled to then give us the context and say, I think that's the temperature at the end of the cutter, based on what he's looking at. So adding the metadata when it's first sampled, when it's first used, closest to the edge, closest to the source, is the best thing you can do to drive any of these cloud ML use cases and avoid the data lake of junk, or the data swamp, as they call it, that you were describing, Dave.
Absolutely. I have worked on those jobs. I have been the guy harassing the guy that already has another job, trying to get them to confirm that these tags mean X thing. Fun fact, Kevin, on one particular project that was supposed to go, I don't know, 4 weeks, that went something like 8 months. We showed up on site to go commission, and we realized like 40 of those tags were wrong, and we had to go fix it as we were back on site going to commission, because oh no, that's not what that's supposed to be. I realized that I either told you the wrong thing or just didn't respond to, I don't know, your 400 emails over the last 8 months. But yeah, I can go fix those now. So we've certainly been there. I absolutely agree. Contextualization, and Vlad and I have had this conversation many, many times. Contextualization is super important. It sets people up for success. As I like to say, Vlad's a hyphens guy. I'm an underscore guy. Rob, who regularly is in the comment, is like, I'm a camel case guy. And I'm like, and this is why we need context when we go deliver the jobs, because none of us are going to be around at this place when we go to redo it, or when we go to make the next major upgrade next time.
And who wants to write that regex, right? It's got to match underscore or dash or camel case, and then maybe dot for some people.
Absolutely.
If I can add, I guess, a perspective, usually I'm the guy who's getting called to understand the tags, and I've been through many, many exercises. And as I've said earlier, I think it's very expensive, right? Once you want to deploy a data solution that makes sense, to go on the production floor and literally audit tag by tag, right? So I was sent to many facilities where I would have to connect to every PLC, then understand the data that's coming in. And obviously, I don't always have the context of the process, right? So what that typically meant is going out there on the plant floor, talking to the operator, understanding what, switch 23 on panel 4 meant, then understanding which, again, because there is no standard, right? So between different machines, temperature tag could be completely different from one panel to the other. So it becomes very costly, very time consuming. Then again, that knowledge, first of all, goes into my head, and then I need to make sure that that's all transformed into something meaningful. And to be honest with you, I've not found I want to say, open source framework. I think there's a couple of examples and companies that are trying to figure out how to better encapsulate that data, right? But the general approach has always been just to have a set based on the company you're working for that has defined that, standard. And anyone comes in afterwards, hopefully you sort of instill that standard into them. But as you go to a different company, they have a completely different standard that you need to either adapt to or completely start from scratch, right? And so it becomes very difficult, right? And I don't think there's an answer for contextualization. And then we can also discuss, or maybe a question for Kevin, when you have complex machinery that you can sort of wrap under one packet, let's say to save some bandwidth. Let's say if you want to say, here's my motor pump that has, I don't know, 2 sensors, 1 vibration, 1 temperature, 2 discharges, and let's say like a motor speed and then calibration parameters. So you have, I don't know, 10 to 50 tags that I want to say, here's a motor pump. And I've certainly seen examples where that's been done well, and then other examples where that's taken to the extreme, where you have a motor pump and then 2 tanks, and then that's also a bundle, and then there's another bundle, and so it becomes so confusing to whoever's looking at that data upstream that they need to unbundle all these tags, and there's no structure, right? Like in our industry, there really is no kind of someone who has put together a set of rules. It's kind of left to whoever. So I was wondering what your thoughts are on further kind of adding data to those tags.
Sure. So, I wish I had the answer, right? This would solve so many problems. I think I've seen a lot of that value, to your point in the bundle, there being value in reading the hierarchy and flowing down and having some sort of contextual information follow along. But in the end, what do you send up? Do you send up just the telemetry metrics robbed of all the bundle context? Because when you get to ML, that becomes just a categorical feature. That becomes just a string label that's applied to a row of data. And so the question is, in the bundle context, did you add value or did you obfuscate, right? Did you make it harder to understand? Once you reach that 2-dimensional flattened grid, which is what you need to start applying ML against it, how much of that context do you need to shed and lose in order to actually start applying algorithms against it? So I wish there was a good standard. And to complicate matters further, I wanted to throw one more variable in. Oftentimes, the sensor that was originally chosen for a given position that is mapped to a certain tag, there's no saying that vendor is still available or it doesn't have a 6 to 12 month backlog for that particular vendor's sensor. So the temperature sensor that gets plugged in as a replacement after it pegs 0 or 100, as you were saying, Dave, might be a completely different vendor because it was available. Not because it was designed or it was better or more durable, just because it was available in 30 days as opposed to 6 months. So even when you've got this mapped, it's entirely possible that different tolerances and different ranges will be expressed from the sensor that you didn't even know was being swapped out with a different vendor.
And that happens on a daily basis, right? Like
Absolutely.
devices get swapped all over the plant. And so
Yeah,
certainly relate to that challenge. Dave?
yep.
Absolutely. No. So I agree with this. I'd actually like to slowly transition over to that machine learning that you were talking about, Kevin. And I know that you are certainly the expert when it comes to machine learning here. Could you kind of walk us through, I don't necessarily want to say a typical, because I imagine there are no typical machine learning applications that you've done, but can you kind of walk us through like a more normal or standard machine learning application so that we can kind of have a baseline to ask some questions about, please?
I'll start with the best statement I can make here, and it should be a relief to a lot of people. You can actually start applying some sort of ML to your data straight out of a historian. You don't need cloud connectivity. You don't need a cloud platform. You don't need to land in a cloud database. If you can do an extract from your historian, if you just do a dump for a given window, given time window, that can be done, moved offline, shared to a vendor, to an internal data scientist, to whomever you're working with, and they can start, we call it EDA, the exploratory data analysis, against this static data set. So they can start to see features that start to arise that contribute. So when you're looking at ML, it's not magic. It's a bunch of math. I'm not a mathematician. I just use the libraries. The mathematicians write the libraries. But the important thing to understand is it's not going to show you anything that isn't there, and it's not going to perform magic. Sometimes the data set you get isn't going to tell you the thing you want to know. And I have the anecdote with the gantry that we talked about earlier that I'm happy to reshare. But you can start with that extract and you can start the process just to get an understanding. And you're looking for correlation, which means you need to have something to correlate to. So typically you're going to look for faults, right? You're going to look for something that has occurred. We had one POC that was focused on stops of the line, right? What were the most strongly contributing features to a line stop? Whether that was a manual emergency stop, whether it was triggered by something automated, but we wanted to find the correlation. So that needs to be the mindset. Get an extract, look for a specific use case and see the features, the signals that correlate strongly with that outcome, whether, using faults as an example. Then you can start to dive down and work with the people on the floor to say, okay, what are these 20 features that correlate most strongly with it? And that's where you start to disambiguate again with the fridge door, the door open, latch, and the light coming on, and you figure out which one actually contributed to the temperature drop. That's the first step. Once you've got those signals, those features that seem to be most strongly correlated, then you can start, building an ML model to predict when that's going to happen, or to be able to start to categorize and say that this set of signals indicates the likelihood of a fault happening. It's not predictive. It's merely saying this is what it looks like. It looks like those signals you showed me that resulted just before a fault. So that is achievable. The question becomes, how do you operationalize that, right? How do you turn that into something that isn't run monthly against the historian extract? You can get meaningful information. You can do some great visualizations, but you can't operationalize from that. Then you make the transition to starting to send these signals to be, we call it making an inference, to use a model to make an inference against the signals that you're seeing. You can do that at the edge, or you can do that in the cloud, or you could do it in both places once you've started to build up on top of that static data set. So that's the start of the journey. That's the beginning of the maturity curve, if you will. And there will be times when there is no magic to show. So if the reason the line stops is because the guy at the wrap and packer is taking a bathroom break and he hits the stop button, all you know is that the stop button happens. Out of one EDA cycle, we found out that there was a reduction in the number of units produced during the night shift. And it turned out the manager at the night shift was just turning down the VFD that controlled the speed of the line because he wanted it to move more slowly so that he could be more in control of it, and it wasn't as taxing on him. So sometimes there's a human component that the ML simply can't suss that out. You could only find it by aggregations and windowing, saying that more faults occurred in this time frame, and then look at what the set points were and then determine it from there. Just sort of a 10,000 foot overview.
If I can ask maybe a basics question, Kevin, if someone's looking to, if someone's working at a facility, right, maybe on the engineering team, and is interested to see what it would take for them to run a proof of concept or like a small project to understand how machine learning would help them, is there a resource that you could maybe share with the audience, or maybe at the end of the conversation we could put that in the description as well? But I'm curious again what it takes to get started, right? And again, I don't have the full visibility and knowledge, like what kind of data structure you're looking for.
Yep.
You talked about like an edge device, obviously, that's going to transform the data, send it to the cloud, but maybe there's a smaller proof of concept that someone at the plant level could just run on, like a server, or maybe a PC that they've plugged in. So I'm just curious if you had that type of a resource.
Sure. So, I mean, at the lowest level, it's a CSV export from the historian.
Okay.
Like if you can start there, that's lingua franca for the data scientists. They can get that CSV and they can move forward with it.
And what does the data look like at that point? Are you looking for multiple points, like one, like how do you start correlating? Or I guess you mentioned like the stops also.
Yeah, so it would be, I would say, pretty much all signals and faults, the thousands of tags that you have in time series format. That's all you need to start. That's enough to feed in and throw the basic ML algorithms against it. And essentially, there's a couple of major use cases, I don't know if they're technically use cases, but approaches that ML will take. Generally, you're trying to figure out if something is part of a given category, a label, right? Is it one of these? Does it look like a red? Does it look like a blue? Or you're trying to predict values to say, linear regression. What's it going to look like in 10 minutes? What's the trend based on what I've seen? Predict what the temperature will be given the following inputs. So those are the two major types of ML that you see thrown against these problems: classification and then some sort of regression to figure out what values would look like given some other inputs. So both of these can be done from that CSV, and they solve different types of problems. Linear regression, the idea that you're sort of predicting the future based on inputs, is what we were doing with that ag tech company. We were predicting the oil yield based on the inputs, the signals that we were seeing. So it's a bit like telling the future based on what we've learned and seen from the data you train the model with. Here's where we look at the oil yield coming out. And then on the other side, it was classification. Does this, on the cleaning product example, does it look like a fault? Does it look like we're about to see a line stop? Does it look like what we have trained you to know as a line stop? So those are the two biggest use cases. And they solve sort of different problems for the customer, and they're different approaches. I would say all of them start with the CSV, but then you're going to need data scientists on the other end. Now, there's a couple ways I'm seeing this done now. So there are bespoke machine learning companies. There are solutions integrators who have data scientists on staff, who have PhDs on the bench, who can take this set of signals and they can do the work for you. They'll do it in their Python notebooks or whatever their tools are, and they'll come back with analytics. That's one approach. And we worked with Quantify, who was a partner of ours last year, on both of the use cases that I mentioned there. The other is folks who have pre-trained a model based on previous experience and previous data sets, who will allow you to bring that pre-trained model into the factory and run your signals against it. So I spoke with TwinThread recently, and this is the business that they're in, of putting together sort of pre-built models focused on like a quality use case, so that you can use your signals with the pre-built model that will retrain and relearn against your signals. That takes the data scientists out of it, but that model will answer the questions that it's built to answer, as opposed to a data scientist who will answer whatever question you ask them to try to answer.
What's an example of a quality model? Sorry, to ask maybe a basic question again. Is that like a visual inspection? Let's say a vision system that inspects a product and then you can train it based on pass fails?
Sure. So it could be that for like a discrete manufacturing example. For the ag company for the soybean extraction, it was oil yield. So that came out of a sensor. That was a numeric value.
Gotcha.
So that would tell you, and I think there was a, again, I'm not that guy. I'm not the math guy, but I think there was some amount of change in weight based on the solution that extracts the oil from the micella, from the mixed organic biomass that's coming in. They could tell by how much that mass changed, how much oil was within it before they then baked it off and saw the oil yield.
Interesting.
So that's an example of, quality, but in a process manufacturing sense.
Dave?
I to quote you, Vlad, have so many questions, right? And I guess those particular, especially the regression models, are things that really interest me, right? Like if we can predict the future based upon what we've done in the past, then it opens up nearly unlimited opportunities. I suppose we could debate as to if that's actually machine learning or if that's just linear regressions and we can do it in Excel, but we won't, because I really don't feel like we need to get in on that. But I think it's interesting, right? Because in my mind, then we just create the tube, right? And if we've got all of our inputs within the tube, we know what our output should be. And then if you're a really smart group, you do your best to make that tube smaller and smaller and smaller so that you can get more and more and more precise. And I always love the ability to go work with groups like that who have enough data and who have enough understanding as to why it's important to be able to go predict the future. That is absolutely great. I do have some more questions. We will absolutely go ask a bit more about this, but first we've got some people to thank. We want to thank Litmus Automation. As soon as I mute this, we want to thank Litmus Automation for going and sponsoring this theme and this show and everything that's going to happen next week over at Hanover. So with Litmus, everyone can work from a single source of truth to improve efficiency, drive profitability, and scale securely when it comes to industrial data. Real-time connectivity, normalization, contextualization, and analysis at the edge come together in one platform to help IT, OT, and enterprise do more with their data. More than 250 drivers connect to legacy and modern industrial systems in minutes, ready KPIs and analytics, digital twins, and machine learning models and integration to cloud available out of the box. Are you going to Hanover Messy? Join me, Dave Griffith, and Litmus to experience real results within reach. We're going to have daily live builds, including digital twin. I think we're going to pull some machine learning. We're going to pull a bunch of integrations in there. We're going to do demonstrations and activities to help make IIoT more accessible. So join us at Hall 17, Stand F18. And we are very excited to go and do that. And we finished perfectly. But no, again, thank you to Litmus. If you guys are going to be in Germany next week, absolutely come and hang out. If you guys are not going to be in Germany, like most of the rest of us, and like me, probably every other year in the rest of my life, come check out this channel. We'll have a bunch of daily live streams, live builds, very similar to what we did middle or end of last month with our energy monitoring build. We should have 4 of those and a bunch of other great content as it comes out. But no, Kevin, so I think that is all very, very exciting. And so I guess while we can ask another like 12 hours of this conversation, I'd like to slowly transition us, right? We talked, I guess we kind of ran up earlier in the conversations, that conversation about data lakes, right? Like, do we want to go fire hose everything up? Do we want to laser beam it up? And I would imagine, depending upon where you live, whether it being a hyperscaler or a cloud service provider, you're going to be like, yeah, go send everything. I think to your point, you said send everything twice because it's just all that better. Those are what our metrics and KPIs look like. But I guess on your side, I'd like to kind of continue that thought from your perspective. Should we go send everything? Do we want another data lake? Where should all of this? Where kind of should all of this live? What is the best path forward in your experience of having done a bunch of these projects?
Initially, like I said, with the bulk extract that you hand over to whoever's running the ML side of the world, you send it all. So the extract, it's a big bulk dump. You move these files, you get it into their hands, they do their initial pass. After that, I'm all for real time should be the minimum number of signals you need you want. I think that there's feature extraction that can be done that will tell you the health of the line. I know, Vlad, you did a perfect example with a single VFD generating half a dozen signals. That you can, via feature extraction, you can just send up one number to say whether or not the VFD is okay and operating within normal ranges. One of the things to do a callback to Litmus Automation that they're really good at, they have some edge processing using Node-RED. It's flow-based to give you the ability to do these running aggregations. If I know your standard deviation, I probably don't need to know what the raw signals were that fed it. And if I know the standard deviation and I know that your signals are well within the standard deviation, why would you need to send that to me in the cloud? What value does it hold? You're basically saying, yes, the door is still closed. The door is still closed. The door is still closed. I don't need to know that information. I would say collapse that as much as possible. So, we talk about on the data side, dimensionality reduction. So reducing the number of signals into fewer, more meaningful signals, and only send the independent dimensions that make it up if it's absolutely necessary to do so. Because otherwise, it's noise that's aggregating in the system. And do you need to store that noise? What value will it bring to you now? What value will it bring to you 5 years from now to know that the door was closed every time it was closed? So for me, I say filter and I say do as much at the edge as you can. So remember that context, trying to look up what the switch 3 on panel 5 was. When you know that, write it at the edge. Don't fill a data lake up with the raw data and then only apply it the analytics layer or a metadata store or a meta store on top of that. Don't apply that clarification there if the clarification can be applied at the edge. Send something that's as contextually meaningful as possible northbound so that you don't have to reconstitute and recontextualize that data after it landed, which is always going to be more computationally expensive because you need to do it multiple times.
Absolutely. So I love that. That very much kind of follows my philosophy of basically less is more, right? And I would imagine Vlad agrees. I guess the hard question, Kevin, is basically that's hard to do, right? Like for a junior engineer, for someone coming in, it is super easy for me to send the raw data as opposed to sending the delta of whatever that is. And then it's in theory, it's easier to send the delta than just send a signal every X period of time saying, yes, we are within range, right? Like being able to give the most information in what I would call more complex calculations that just get fed to the model, and I assume would make the model simpler and easier to digest and provide real-time value is easy. So the question is, how do we convince people
to make the investment
forward
up front? Yeah.
Yes. And to like, one, how do we convince end users to make the investment up front? But two, how do we convince, be it integrators, be it service providers, be it end users, that we really want to have better raw data with more contextualization in the smallest form possible, as opposed to just sending a bunch of interns with a laptop and saying, just go send everything? Because sending everything, again, is easier.
It's easier, but it leads to exactly the scenario we talked about. We used to call it the game of fetch me a rock. Go get me a rock. They bring back, not that one. Go get me another rock. That's what you play with the poor plant engineer, because you'd go send him to give you the definition of every single tag that might potentially be meaningful. I think it's worth setting the expectation with the customer that there is an upfront investment. Unfortunately, the executive might have been sold on predictive maintenance, and I have a whole diatribe I can get onto for predictive maintenance.
Oh, me too.
Show me enough failures, and then I will help you predict the next one. Give me a data set with no failures. How the hell can I predict it? It's just I don't know what it looks like, right? It's not magic. So set the expectation up front that there needs to be some sort of investment. Now, whether that's the litmus guys going on site and extracting, whether it's an SI, whether it's somebody from your IT department that owns that data side of the world, somebody needs to make that case to invest up front, because it'll make the whole rest of the process easier. Deferring that task it's putting the burden on somebody who is expensive and is going to be delaying the process every time you have a use case and every time you have a question. It's easier to ask the plant engineer when you're sitting next to him than it is 3 weeks later when you're trying to get the dude off of the plant floor, right? Interrupting his day in between updates and checks that he's doing to come sit with you for 5 minutes and tell you he doesn't know what the tag means.
I would say, go ahead, Kevin.
I was going to say that's my advice: is the investment up front will pay dividends throughout the whole process.
I would say what I've seen typically, at least like on the projects that I've been on, is that you need to have at least some milestones in mind, right? Because I think if your goal is to just collect all the data, that's where people to some extent not necessarily get discouraged, but don't see an end in sight. And so that's where you maybe start to cut corners because of just the amounts of data that you can be sending. And so if you have a very specific, like, hey, we would like to focus on this, like one specific machine, here's the current, trend line of the OEE, let's say, metric, and we know this is the bottleneck. We would like to collect the data that will allow this machine to improve by, 5-10%, depending on the facility. And so everyone's focused just on that, right? And at that point in time, you need to really know what information you want to get, at which rate, at which deltas, with what context. And so there's almost less ambiguity, and there's less, the plant engineer cannot just make the call, we're going to get it with zero context, we're going to get it with zero processing, or whatever else, right? So it becomes very clear what needs to be done, at least from what I've seen.
Yeah, I would agree. And I would say that needs to be tied to a business objective. So your point of tying it to OEE, that's money, right? You can tie that directly in. You can make the cost justification for doing it. I think oftentimes you end up in science projects, right? You get a motivated person who is, tech friendly, who says, I've seen all of these podcasts, I've seen all of these videos. I'm ready for predictive analytics. I'm ready for machine learning to revolutionize.
Yep.
And they come in and try to enforce it onto the plant where, they're just trying to hit their numbers, right? They didn't have a spare budget. They didn't have spare time for this. So I love the idea, set milestones and tie them directly to business objectives so you can show ROI to the folks further up the food chain. Prove it's not a science project.
Kevin, I do have a question, I guess, with that in mind. So we discussed a little bit earlier the two-way data transmission, right? And I've certainly, personally, I've not seen a lot of projects yet where you can reactively also maybe adjust parameters in your process. I've seen a lot of it being done, the more traditional way where somebody in the cloud looks at that data. It could be a scientist, but most likely it's, just a dashboard that kind of allows you to see the trends, and then we make an adjustment. Then we take, let's say, a week or 2 weeks to see what's going to happen, and we're going to readjust through that process. Like, have you seen this maybe faster closing the loop kind of model that works, let's say, at the edge, that adjusts some control-based parameters almost in real time? I don't know if it's in real time. I'll leave that up to you, but I'm curious of those applications.
Yeah, so you're talking adaptive controls, right? You're talking closed loop system where the model is trained in the cloud, and then the completed model is brought to the edge, and then that's used to control. So it always starts with a recommendation. There needs to be a vetting process, and value that your recommendations make sense before anybody will trust you. So as part of the POC, you can set that adaptive control closed loop being your North Star. That's where we're going. And the milestone you spoke of, first it's collect the right signals, then it's identify the meaningful features, then it's provide recommendations back, and you're going to sit there for a while. You're going to sit there showing recommendations saying, hey, look, I'm not telling you to turn it to 11, right? I'm not giving ridiculous advice that's going to kill the guy at the end of the line. You have to build that trust by giving sound recommendations. I think the biggest challenge we faced was it is almost easier to tell the future than to ask the future what I should change in the present. It's easier to say, hey, look, this is clearly the signal is trending, right? And based on the input signals, my temperature is going to be too high. It's going to trigger a shutdown. Knowing which set points to adjust, knowing which, parameters to change to cause that to come down is much more complicated, requires domain expertise, requires some experimentation. So especially in a complex piece of equipment, it's not one knob that you will change. You change one knob, you change the speed of the line. Okay, now the speed of the extruder has changed. Now the speed of the cutter has changed. Now the speed of the wrap and packer has changed. You've impacted a complex system by turning a knob. And until the machine learning model has seen the results of that change, it's hard for it to meaningfully recommend that change. It knows that it's a strong feature contribution, but these are complex items. You need to see how this system behaves when you turn one of the signals. So part of the process is that recommendation, but to get to that recommendation, you need to know what the impact of adjusting the controls will be, and that will require some amount of data capture.
And it's super interesting, right? Like, again, I want to piggyback on what I see at least, but I think in our mind, it's very easy to picture a single PID control loop, right? If I'm, let's say, controlling the level or a set point of a temperature, I can very easily go in there and program that because I can visualize what happens to my trend as, the heater turns on, turns off at the very simple example. But as soon as you start having, let's say, two control loops that, let's say, start fighting each other, that's when it becomes almost impossible to visualize. And as you layer those variables, like you've mentioned, on top of each other, it becomes, I think, like the human brain almost at this stage cannot sort of like wrap their head like around the data. So it's going to be really interesting, right? And I'm curious like how far it's going to push it, because I think machines are very adaptive to those scenarios, right? And lend themselves very well to all those multivariate problems. But
Yeah.
again, I think it's going to be interesting to see what comes out in the next like couple of years, even a decade.
Yeah. And I think once you've done that, once you've closed that loop, you then have to constantly retrain the model so that it learns what the new set of signals looks like. You've trained a model based on that initial extract or based on some amount of time worth of data capture. If you've changed the set points, you've changed the behavior of the system, you're retraining the model as you go. And that brings up the major question: is this training in the cloud or is this training at the edge? If it's in the cloud, how the hell do you get it back to the edge? Right? With an OT team that will not allow any binary data to come flowing back down over the SSL connection, the HTTPS connection, and mutate a system attached to their line. So that becomes a delicate balance. A model at the edge that can self-train, that can learn and can adapt is better suited to this type of system, but you have less computational power, right? It's not like throwing massive amounts of cores at it like you can do in the cloud, or having an offline data scientist who's ready. There won't be a data scientist on the plant floor, right? We ask enough out of plant engineers already. It's asking a bit much to tell them to go back to school for data science. So I think that becomes an almost religious conversation. Do you want to make it cloud focused and get the benefits of more horsepower, more expertise on the ML side, or do you accept somewhat lesser scope and lesser horsepower, but a tighter control loop and no round trip conversation?
I'm hoping that it can scale. No, it's probably going to be application specific. But let's say, again, if I have one machine, I can maybe deploy it at the edge. But as soon as I need to scale that past a certain number of tags, it becomes too complex and just too data intense. But obviously, there's a lot of variables even in deploying that, right? Because then your funnel to the cloud becomes also a question: what your connectivity or just ISP provider, right? Like just being able to send those packets in real time becomes a challenge in many industries, right? So there's a multivariate question there as well, but my hope is that it can scale and apply to like a specific application, right?
Yeah, and what happens if somebody on the IT side accidentally pushes out a new firewall rule and stops that communication? Does the line stop? Right? Once you've tied
Probably
the
get
cloud into
fired.
that loop. Yeah. But how do you once you become reliant on the cloud, it's tough to tell somebody that a device locally won't work just because something has happened further upstream.
Right.
So this is a great philosophical question I don't think we've answered yet. I've seen a lot of players starting to address this. And I've seen some players saying permanent cloud connectivity. This is how we're going to manage it. It's, it's the base, requirement for us to go through and try to do ML at the edge. And I've seen other folks that say, we're going to deploy pre-trained models to the edge that are just going to teach themselves and learn as they go. So there's, multiple approaches to solve the problem. And I think it really depends on whether you can get good enough with just the edge component. Because if you could do that, then I would do that every day of the week. It eliminates a whole dependency up to the cloud.
Interesting. I guess I will say a little bit of context for Kevin and anyone who hasn't listened to every episode of Manufacturing Hub. This has been Vlad's mad science experiment of can I run everything in the cloud? Yes. So thank you for inadvertently restoking that fire, Kevin. I will be having to have this conversation with Vlad for at least another 3 months. But I will say I have worked with organizations who were at least heavily dependent upon the cloud, and if we have an issue with the connection, we don't run production. So I've had to have the conversation of, because we're pushing everything up and down to and from the cloud, and there's an issue somewhere in this connection or this network, it's not working. And that is never a conversation anyone wants to have. And while I certainly understand the concepts of more cores, more data scientists, more horsepower in general, like there are really good things at the cloud, I would say in a not small percentage of small, medium, and even large manufacturing companies, like internet on the plant floor and like across the plant floor, much less internet connectivity that is fully stable with 99.99% SLAs to the facility is just non-existent, right? So we are connectivity a long way away from that. What I think is really exciting is the opportunity to do some of this at the edge, potentially connect and get some training up and down from the cloud from whatever edge devices we're particularly looking at, go train that model, and then still allow us to run on the edge if and when we have connectivity issues. It's the same reason I talk about putting edge gateways or panel views or whatever you want at a variety of critical machines. If X thing goes down and it's the single source of failure, are we okay taking the facility down for this one thing? And the answer is almost always no. So it would be really difficult to have that conversation of, hey, we spent, I don't know, our entire lives removing single sources of failure. We've got redundant PLCs, we've got redundant servers, we've got redundant, fiber running to and from buildings. But our single source of failure is now something basically completely out of our control. And if the guy doing street maintenance, 20 miles away accidentally cuts our fiber bundle, then we're down for weeks, days, a long time. So I think that is certainly going to be a difficult conversation to have. But I think that there certainly is that middle ground. And I look forward to seeing those applications, especially looking at maybe edge providers and cloud service providers working together, realizing that connectivity on the plant floor is certainly never
occasionally
100%.
Connected was the term we used. So occasionally connected, like meaning you can pull an update, you just can't guarantee when it's going to happen. And that's something, if you're starting down this journey, work with your vendors and find out how they work in a disconnected environment. For what it's worth, Litmus Automation does store and forward. Yeah.
Oh,
so they can handle connectivity.
I love it. I love it. We've actually had a number of store and forward conversations here. I guess I'm personally a big fan of store and forward. I've used it everywhere from, I don't know, remote landfills where we've got at best 20% uptime on our cellular or satellite or wireless radios to, facilities where we've got, 10 different buildings in this complex. And at least in one of those times, I have watched as someone redoing the parking lot cut through a fiber bundle, and we quite literally could not run without store and forward capabilities as they went through and took the week or whatever it was to replace that fiber bundle. There were a lot of upset people, but it would have been a critical failure, right? Facility would have been down for potentially weeks had we not have that store and forward capability. And honestly, that's something that I almost take for granted, because virtually any application that I look at is going to have store and forward, because I've lived on the back end of that of, hey, we're down because we've got this single point of failure. But just based upon conversations we've had with chat and otherwise in the last, month or so, it makes me realize that not nearly as many people have store and forward as a critical functionality on their edge or gateway or other applications.
That's got to be top of the list, when you're doing your evaluations.
Agreed. But no, Kevin, this has been an amazing conversation. I feel like so much of this conversation has been future focused, but as I have forewarned you, I like to ask everyone to go ahead and predict the future. And so I guess I'm going to leave it super broad as to what you think the future is going to be. And then there may be a couple of follow-up questions of what that looks like. But what do you think that the future of this is going to look like?
It's automation. So like I said, I've not visited a plant that didn't have dozens of openings. Just getting physical humans in the building to perform the job is now becoming near impossible. Now, I'm not saying we're going to go down the road of the frankly terrifying Boston Dynamics robots who are capable of, athletic feats that I'm incapable of. But I do think we're going to see a lot more closed control loops. I think we're going to see a lot more self-healing. There'll be a lot more of this, adaptive control systems in order to get over that. I think a lot of the tasks that humans perform are boring, repetitive, high-stress activities. Those could be not even the thinking the independent Boston Dynamics, but more the cobot scenario, right? That can coexist in a human workspace, with threat in proximity detection to not go harming people, following all of Asimov's rules. But I think you'll have more of that to replace the missing human workers.
Interesting. I think that is very valid. We are certainly not to the point of our parents or grandparents happily going to work at the factory for, I don't know, 40 years and then retiring with a pension. I also, most facilities that I work at have issues getting and keeping and retaining those people. And it doesn't matter if it's a new facility or if the facility's been there for 70 years and lots of people have been there for 30 years, everyone has retention issues. So I certainly think that we will find solutions deriving around that. And then I guess I want to, as a follow-up question on the machine learning applications, and I'm going to ask you because you are about as independent as anyone can possibly be at this very moment on April 12th, 2023. Kevin, what do you think, I guess, where are we going to do a lot of this machine learning, artificial intelligence? Is it going to be the edge? Is it going to be the cloud? Is it going to be some sort of hybrid based upon your experience?
So it's going to be cloud training, edge, inference. So that's where we're going. So the big models will be trained. It'll be exported down to the edge. And then there might be some, we call it transfer learning, when you take a model and you apply new data sets on top to refine it. There'll be some amount of that transfer learning to keep the model fresh, to keep the model updated. But I still think the bulk of the model development will still be happening in the cloud. Maybe offline, right? Maybe the EDA that I talked about, historian exports, maybe that's the path, but I still believe it'll be cloud for the training for the foreseeable future.
Absolutely. And honestly, there are an awful lot of facilities that could use even the smallest bit of that, or someone who knows what they're doing going and getting a look at the process and telling them that it's all wrong. Vlad has
I have a career question, Kevin. If I can ask you, so a lot of our listeners are on the OT side, I want to say. We certainly have people from the IT as well. But if I'm an engineer on the OT side, if I'm currently, programming a lot of the automation systems that you see on the production floor, what kind of advice would you have maybe from a technology side, right? So we talked about data science, we talked about machine learning, we've talked about cloud computing, there's obviously networking, server technologies. A lot of those are almost a career in themselves. What advice would you give for someone who's currently doing OT? Should they be learning one of those? Should they be understanding more like Python programming? What is your thought on what could be a good edge for someone who's currently on the OT side to learn?
Sure. So the first step would be look at what expanded capabilities are available for the existing suites that you're using. Are you an OSI Pi shop? Are you an Ignition shop? There are additional modules available that are pre-built that are going to do a lot of this heavy lifting for you. So just because you may not have purchased the module doesn't mean you can't go get trained on it. Doesn't mean you can't go look into it and research it. So expand out from where you are today. Don't think you need to go completely new and start, trying to get a cloud certification. Expand on what you know and bridge as far up that stack, up the cloud stack as you possibly can within the existing ecosystem you're familiar with. Those are smaller steps, easily digestible, more comfortable.
Interesting. Dave?
Absolutely. I agree. I think that is great career advice. And I was probably thinking to myself the same thing Vlad has been thinking to himself is, would it be interesting and do we have enough time to go become data scientists? I would imagine the answer is going to be a solid no, but I'm just going to throw that inside thought out. But Kevin, so I always like to ask for a book recommendation, and I, for the longest time, joked that it was a hashtag not sponsored Audible recommendation for Vlad because he needs to go utilize his Audible monthly sponsorships. He's got like 250 of these books downloaded. So I know you've got a couple of book recommendations. I've got an awfully long set of plane rides and train rides coming up. So I would love some book and or content.
Okay, I'll give you two. One book, one series, which I guess is a cop-out. I'm nearing the end of the Expanse series of books. Sci-Fi Universe. It started on the Sci-Fi Network. Amazon finished it, so you can actually watch the series on Prime, Amazon Prime. Masterful. So I would say in the achievable near-term future, there's no magic involved. They wonderfully broke the solar system down into the people who lived on Earth, people who lived on Mars, and the people who worked in the belt mining for the rest of us to get water and oxygen. And it has crazy parallels with like Cold War era geopolitical structures where people are slotting into their roles. And various, we'll say exploitation happens as a result of these roles and positions. Wonderful, wonderful. And then in terms of not science fiction, Guns, Germs, and Steel by Jared Diamond. He's a professor. I think he's a Stanford professor. It was a wonderful look at how societies evolved and the external factors that governed that. And he started with the question of, why did Spain invade Peru? Why didn't Peru invade Spain?
Mm-hmm.
And then it goes through how these civilizations evolved. And again, these external factors that you would never think of, like, does your continent have a primarily X or Y axis? That has a major impact on it, based on the ability to, have agriculture that can be moved thousands of miles horizontally, as opposed to seeds which can't survive, halfway across your continent because you're primarily north-south. So wonderful tidbits like that. But that was a mind-expanding read for me.
Interesting. I love that. I think Guns, Germs, and Steel will be on my my list. I will say I've not read the Expanse series, but I've watched the series all the way through once, and I've got this thing where I watch series, and somewhere around the point that I think it's peaked, I stop watching. So I've watched a bit, half or 2/3 of it again the second time. I have not read the books. I think the books will be on my docket. I believe there is a Kickstarter out for an additional book or something like that. I have not joined the Kickstarter because I haven't read the first, I don't know, half a dozen books, so I probably shouldn't
I have
go
joined.
kickstart the next book. But
I'm a backer.
Okay. Good. So I think that all of those are great. Hank in the chat is saying Audible is his travel companion, which is good because Hank has been doing an awful lot of travel the last couple of months. And then Kevin, I guess the last question for you is who should reach out? Who do you want to talk with? I know you're in some part of a career transition, but kind of you're open forum to ask all of our listeners anything that they
sure.
that we
so
and they can do.
Just reach out to talk to me. Pretty much anybody in this space. I'm in interview cycles with a bunch of IoT companies. So, my next location is TBD. Google, upon laying me off, gave me the largest bonus that I ever had working for Google, which was wonderful of them to pay me to not work for them. So I'm spending some quality time finishing up the barn that I'm going to retire to in Vermont. Wonderful timber frame structure out in the woods. So I can have conversations now that I have not been able to have for the last 15 years because I'm not currently accountable to anybody commercially. So I can give honest and impartial advice. And not merely, boost the people who paid for my health insurance. But I will say that I'm friends with the Litmus team, and I'm a Litmus booster because of my work with them. I gain nothing financially by saying it.
I love that. I will say that I am super jealous of the timber frame barn. I don't think it'll be in Vermont, but my wife and I have had many conversations of that over the years. So I am jealous to see where that goes. If I ever have, I don't know, 5 years of my life, I will go build a timber frame, something or other from scratch. The farther I get into that internet rabbit hole, the longer and longer you realize it takes to actually go build it, especially if you want to do it all by hand.
I paid guys with cranes to do the bulk of it. So now I'm doing the finished work.
And that is absolutely the right way to do it, Kevin. I've watched a couple of people go buy their Japanese chisels and cut down the trees themselves all the way through finish. And I just don't have 10 years of my life to do that. I have other things. that are more valuable to the world and all of our listeners. But having said that, again, thank you for everyone hanging out with us. Hey, again, to all of our Solus PLC listeners, thank you for always hanging out with us. A couple of wrap-up notes. I will say, just a reminder, if you guys are catching the end of this live, come check me out at Hanover Messy. If you guys are listening in podcast form, I will be there on Friday, which is either the day before you're listening to this or the day that you're listening it to, depending upon when we get it out and when German time is. But please come check us out at Hall 17, booth F18. Come say hi, come grab some stickers, come do all of those things. Again, a big thank you to the Litmus folks. And then if you guys are listening, please hit the thumbs up and like button. Please follow Manufacturing Hub. We as a page just surpassed 2,000 likes on LinkedIn, which is awesome. Solus PLC is like at 38,000 subscribers. So if you guys are watching on Solus, please subscribe to Solus, where you guys get to watch us live every week. And Vlad also puts out a bunch of absolutely great content, which is how he built almost all of those 38,000 subscribers. And if you guys are listening in podcast form, please go rate us 5 stars everywhere you can rate us 5 stars. Please hit the follow along button. You guys get new podcasts every Thursday. And until next week, we'll talk to everyone.